Okay, in this video we are going to be talking about scalar quantities and vector quantities. Let us try by all means to give ourselves an understanding concerning what these things are. So basically, when you're talking about physical quantities can be classified into two ways. The first way, they can be classified as either basic quantities or derived quantities. The other way in which they might be classified in is in being either scalar quantities or vector quantities. Okay, so what are scalar quantities? What are vector quantities? This is the first question that we're going to start asking ourselves. What examples can we put under scalar quantities? What examples can we put under vector quantities? What differences can we even give concerning these two things? Well, scalar quantities. We'll start with scalar. Scalar quantities. These are just physical quantities. These are just physical quantities which have magnitude. So the other term which you can give for magnitude is size. So physical quantities, these are just scalar quantities rather. These are just physical quantities which have magnitude but no direction. Okay, but no direction. But there are others which have direction but not just a specific one. Okay, so if you want, you can say that these are physical quantities which have magnitude but no direction, or better say which have magnitude but no specific direction. Others do have direction but not just a specific one. So that's how we can define scalar quantities. So these are just physical quantities which have magnitude but no direction, but no specific direction. Examples that we can give for scalar quantities, physical quantities which have magnitude but no direction. We can talk about mass. Mass is an example of a scalar quantity. And please take note, these are not physical quantities which do not have magnitude and direction. They have one thing, but they don't have the other. They have magnitude. They have it, but no direction. We can talk about mass. Mass is an example of a scalar quantity. We can also talk about time. Time as well is an example of a scalar quantity. Okay, time as well is an example of a scalar quantity. We can also talk about temperature. Mass, time, temperature. Yeah, I think this can suffice for now. So mass, remember, kilograms. Time, seconds. Temperature, kelvins. Yeah, I can even put the amount of a substance. Amount of substance. All these are examples of scalar quantities. And we saw that the amount of substance is expressed in moles. We can also put energy. So all these are examples of what we term as scalar quantities. These are quantities which have magnitude but no direction, but no specific direction. Okay, yeah, even speed. Almost forgot that one. Even speed. It's a derived quantity whose units are the meters per second. Derived units. So that's what we can say for now, at least, on what scalar quantities are. But what are vector quantities? What can we say about them? What are vector quantities? What can we say about them? Okay. Now, when you're talking about vector quantities, vector quantities, vector quantities. Vector quantities are quantities which have both magnitude and direction. These are just physical quantities. These are just physical quantities. With both. They have them both. With both magnitude and direction. Very important for us to understand this. So these ones have both magnitude and direction. Okay, so what examples can we give under vector quantities here? What examples can we give? What can we say about them? So examples of vector quantities that we can put here are mostly those which are discussed under kinematics. We can talk about velocity. Velocity is a vector quantity, meters per second. We can talk about acceleration. Acceleration, units meters per second squared, right? Meters per second squared. We can also talk about force. Force, we all know that the units are the newtons, right? Yes. Velocity, acceleration here, the force. Also not forgetting displacement. Displacement and just general distance are two different things. Displacement. And of course, displacement is just measured in meters. Those are the SI units. Okay? So, these are vector quantities. Physical quantities with both magnitude and direction. Examples that we can give: velocity, acceleration, force, displacement. Alright? These are examples of what we might refer to as vector quantities. And speaking of direction, velocity, acceleration, force, displacement, these vector quantities can be, can I say, split into different components depending on the type of direction they are actually involving. So when you're talking about direction here, direction can either be in the x-axis, it can either be in the y-axis, it can also be in the z-axis. Okay, so depending on direction, these vector quantities can be resolved into different components depending on the types or kinds of direction which it is being oriented in. Like a good example, when you're talking about velocity, let me write it here. When you're talking about velocity, if the kind of velocity that you are addressing in that problem, if the kind of velocity that you are addressing is in 2 dimensions, in 2D, that is involving only the x and y axes or motions or directions, your velocity, which in this case is v, when we resolve it into its components, it can either be vx and vy. Okay, it can either be vx or vy. If there was also a z aspect there, we would have also put vz. But if you're talking about maybe say velocity in 2 dimensions, velocity can be resolved into two components, which are Vx, Vy. If it's force, it's also going to be in the same way. It's going to be Fx, Fy. If it's acceleration, something Ax, Ay. So how can we resolve, or how can we calculate these components of a vector? Okay, how can we calculate these components of a vector if maybe say a question has been given concerning them? We can derive it in this way. Let us imagine you're starting from this point, and then this particular line is representing your vector and it's heading in this direction. So let that vector be V. Okay, let that vector be V. Maybe say this is point O, you're going to point A. So let that vector be just V, just generally for velocity, acceleration, force, inclusive of the displacement. Alright, now you're going to notice that there is an X path that can be taken here. This X path just beneath this V component, this X path can be termed as the Vx, which means that the velocity V here, or the vector V here, its X component is being expressed horizontally, that is Vx. Now going up to A, we can go downwards. Remember, these things have a specific direction, so I'd rather head upwards. So have you seen this one? This one is more like following the y-axis. So this component here is going to be your vector y. Okay, so this is the y component for this v here. Okay, this is the y component for this v here, and the angle here definitely is going to be theta. There is an angle that is being generated as these components branch out, and this angle here is being made specifically between this vector with its x component that we have down there. It's a 90 degrees triangle pattern that is just going to be created. So if you use your basic trig ratios here, you can actually derive to say that Vx is going to be given by the formula V cos theta, and Vy is going to be given by V sin theta. These are the two formulas that you are going to use to determine your components of your vector. So maybe say you are talking about force as your vector here, and maybe say it was 25 newtons. If you're going to calculate its x component and y component, this is just going to be, if it was 20, it's just going to be 20 cos the angle that you have there. And if you're trying to find for the y component, that's just going to be like 20 sine of the angle that is there. Okay, yeah. So having seen that this is a triangle, definitely Pythagoras theorem can work here. So the other formula that we can issue ourselves with is this one. Your V is always going to be equal to square root of Vx squared plus Vy squared. So that vector is simply a resultant of its components. It's a resultant of the x and y components together. So V is equal to the vector, that is square root of its components Vx squared plus Vy squared. So that's just an addition that I can give under vector quantities. In terms of direction, they can be expressed or resolved into different components. x, y, z. If you're talking about motion in one direction, movement in one direction, just x, y, or z. If it's in 2 dimensions, it can be x, y. Yeah, mostly x, y. Okay, the x, y plane is the one that is normally used in that way. But if you're talking about motion in 3 dimensions, this is where you're going to consider the x components, the y components, inclusive of the z components there. All right, so this is very important. So for now, just try to grasp these formulas. So that's what we can say in this video concerning scalar and vector quantities.